Bismillahirrahmanirrahim. So today we have a new test, some new problems which are tricky, not difficult. So let's start. Graph of volume versus total pressure at constant temperature is, this problem is actually not difficult at all, but the options given are in a different way, which makes it difficult for the students to give the answer. Now what are the options? A straight line, first a straight line, then a curve, first a curve, then a straight line, and non-linear. So when you look at the statement, graph of volume versus total pressure, two things are given. This is volume V and this is pressure P. So you have to make a graph between V and P. And what is constant? Temperature is constant. So we know that this is what? This is Boyle's law. V is inversely proportional to the pressure. The graph of Boyle's law is a hyperbola. So when you look at hyperbola, you can find it that it is a curve. It not meets with the first option, the second option, and the third option. The hyperbolic graph is a non-linear graph. So the correct option is 4. Now move to the next one. Which one of the following is the angular speed in radian per hour for daily rotation around our earth? So what we have to find? We have to find out the angular speed in radian per hour for daily rotation around our earth. So the speed is given by omega is equals to 2 pi over t, where t is the time period, the time required to complete one cycle. In case of earth, the earth took 24 hours to complete one cycle. So what we'll do is 2 pi divided by 24. This is 2 ones are 2 and this is 12 times. So which is the correct option? This one. Pi over 12 is the correct answer. A rotating wheel coincides 12 revolutions in 4 seconds. So number of revolutions per second. How many revolutions? 12 revolutions. In how much time? 4 seconds. 4 ones are 4, 4 threes are 12. This is 3 revolution per second. Now find the average angular velocity in radian per second. This is the angular velocity, but it is given in revolution per second. So we have to convert it into radian per second. We know that one revolution, one complete cycle equals to 2 pi radian. So for 3 divided by second on both sides. Now what we'll do is, we have 3 revolutions per second. So this will be 3 revolutions per second equals to 2 pi multiplied by 3 radian per second. So now solve this. This will be 2 into 3.14 into 3. This will be 6.28 multiplied by 3. So make the multiplication and get the result. 6.28 into 3. 3 8s are 24 ka 2, 2, 3 2 are 6 and 2 8 and 3 6 are 18. So 18.84 radian per second. So this will be the correct option. This is the most interesting. A fighter plane is moving in a vertical circle of radius r. Its minimum velocity at the highest point of circle will be. A fighter plane is moving in a circle of radius r. Now this is the highest point. This is the highest point. Here we have aeroplane is lying over here. It should be noted that we have to find out the minimum velocity. When it has minimum velocity, this will be just balanced with the weight of the aeroplane. At this particular point, there are two forces. Number one is the weight of the aeroplane, which is acting downward. Other is the centripetal force, which is moving and keeping the aeroplane on the circular path. So this is Fc and this is W. Both should be balanced to have minimum velocity. Centripetal force is given by mv square over r. Weight is mg. M cancels with m. V square is equals to gr. So V is equals to under root gr. This is the correct option. Now move to the next one. If a flywheel is rotating at 3 radian per second, so this is angular velocity omega 3 radian per second. The time it takes to complete one revolution is about, we need the time period t. We know that the angular frequency is related with time period by the formula t is equals to 2 pi over omega. So here we have 2 pi in the numerator. Omega is 2 pi radians. This is in radians. And omega is 3 radian per second. Radians cancel with radians. Second will go up. So t is equals to 2 pi is 3.14 and this is 3 and this is second. So simplify further by removing this decimal point. When we remove this decimal point, we'll get 100 in the denominator. So we're left with 628 divided by 300 seconds. We can see that 628 divided by 300 will be 2 times. This is 628 remaining. Decimal 0 not going. Again 0. 3 nines are 27. 100. So and so forth. So 2.0109 is not given over here. When we round it off, it will become 2.1 second. So this is the result. Okay, take care. We'll meet with the next problem next time, inshallah.